Good morning. In continuation with Chapter 15, Biodiversity and Conservation, today we are starting with the topic Patterns of Biodiversity. Latitudinal gradients. Now, the diversity of plants and animals is not uniform throughout the world but shows an uneven distribution. For many groups of animals and plants, there are very interesting patterns in diversity. The most well known is the latitudinal gradient in diversity. Now, species diversity decreases when we move from equator to the poles, and tropics have more species than temperate, and Colombia, located near the equator, has nearly 1,400 species of India, and New York at 41 degrees north has 105 species, and Greenland 71 degrees north has only 56 species. India, with much of its land in the tropical latitudes, have more than 1,200 species of birds. A forest in a tropical region like equator has up to 10 times as many species of the vascular plants as a forest of equal area in the temperate regions like the Midwest of the USA. Tropical Amazon rainforest in South America has the greatest biodiversity on earth. So it is home to more than 40,000 species of plants, 3,000 of fishes, 1,300 of birds, and 427 of mammals, 427 of amphibians, 378 of reptiles, and more than 1,25,000 invertebrates. So scientists estimate that in these rainforests there might be at least 2 million insect species awaiting to be discovered and named. Now, ecologists and evolutionary biologists have proposed various hypotheses, and some important ones are speciation is generally a function of time. Now, unlike temperate regions which are subjected to frequent glaciation in the past, tropical latitudes, they have remained relatively undisturbed for millions of years and had evolutionary time for species diversification. So tropical environments, unlike temperate ones, are less seasonal, relatively more constant and predictable. Such constant environments promote niche specialization, and that leads to greater species diversity. And there is more solar energy available in the tropics, which contributes to higher productivity, which in turn might contribute indirectly to the greater diversity. Species area relationships. During this pioneer and extensive explorations in the wilderness of South American jungles, the great German naturalist and geographer Alexander von Humboldt observed that within a region species richness increases with increasing explored area, but only up to a limit. The relation between species richness and area for a wide variety of taxa like angiosperms, plants, birds, bats, freshwater fishes, that turns out to be a rectangular hyperbola, as we see in this graph. You can see here in this graph showing the species area relationships. Note that on the log scale the relationship becomes a linear. So here we find that the relation between species richness and area for a wide variety of taxa like some of the angiosperms, plants, birds, bats, freshwater fishes, that turns out to be a rectangular parabola. And on a logarithmic scale the relationship is a straight line, which is described by the equation log S is equal to log C plus Z log A, where S is the species richness, A is the area, Z is the slope of the line, that is regression coefficient, and Y is the intercept. So ecologist C is equal to y-intercept. So ecologists, they have discovered that the value of Z that lies in the range of 0.1 to 0.2 regardless of the taxonomic groups of the region, whether it is plants in Britain, birds in California, or mollusks in New York. The slopes of the regression line is amazingly similar. But if you analyze the species area relationship among very large areas like the entire continents, we will find that the slope of the line to be much steeper, and the z value in the range of zero 0.6 to 1.2. For example, the frugivorous, that is the fruit eating birds and mammals in the tropical forests of different continents, the slope is found to be 1.15. Now, the importance of species diversity to the ecosystem. Does the number of species in a community really matter to the functioning of the ecosystem? This is a question for which ecologists have not been able to give a definite answer. For many decades, ecologists believed that communities with more species generally tend to be more stable than those with less species. What exactly is stability for a biological community? A community where should show too much variation in productivity from year to year. It must be either resistant or resilient to occasional disturbances like natural or man-made, and it must also be resistant to invasion by alien species. So species diversity is actually the variety of species in a given area, and species diversity is important because species ensure that ecosystems survive. Now, why each species depend on the services provided by the other species to ensure their survival. It also creates a balanced ecosystem which ensures ecosystem services function properly too. So everything is interconnected. Now here we find that we don't know how the attributes they are linked to species richness in a community, but David Tillman long-term ecosystem experiments using outdoor plots provide some tentative answers. Tillman found that plots with more species showed less year-to-year variation in total biomass. He also showed that in his experiments that increased diversity contributed to higher productivity. So we may not understand completely how species richness contribute to the well-being of an ecosystem. We know enough to realize that rich diversity is not only essential for ecosystem health, but it is also for the survival of the human race on this planet. Now we are losing species at an alarming rate. Does it matter to us if a few species become extinct? Would Western Ghat ecosystems be less functional if one of the trees or frog species is lost forever? And how is our quality of life affected if instead of 20,000 we have only 15,000 species of ants on the earth? There is no direct answer in such naive questions, but we can develop a proper perspective through an analogy. That is also called as rivet popper hypothesis, that is used by Stanford ecologist Paul Ehrlich. And in an airplane ecosystem, all parts are joined together using thousands of rivets, that is species. If any passenger traveling in it start popping a rivet to take home, causing a species to become extinct, it may not affect flight safety, proper functioning of the ecosystem actually. So initially, but as more and more rivets are removed, the plane becomes dangerously weak over a period of time. So which rivet is removed may also be critical, and loss of rivets on the wings like key species that drive major ecosystem functions is obviously a more serious threat to flight safety than loss of a few rivets on the seats or windows inside the plane.